Mixtures are all around us, from the air we breathe to the food we eat. In this chapter, we will explore what mixtures are, their different types, and how we can separate their components using simple physical methods. Understanding mixtures is a fundamental concept in chemistry for 6th grade students. A mixture is an impure substance formed when two or more pure substances, like elements or compounds, are simply added together without a chemical reaction. The individual substances making up a mixture are called components or constituents, and they can often be separated by simple physical methods. Examples of naturally occurring mixtures include soil, air, and tap water. Mixtures can be classified into two main types: homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture has components that are evenly distributed and cannot be seen separately, giving it a uniform appearance. Examples of homogeneous mixtures include salt solution, honey, and cola, where everything looks the same throughout. In contrast, a heterogeneous mixture has components that are unevenly distributed and can be seen separately, resulting in a non-uniform appearance. Common examples of heterogeneous mixtures are pulses, sand and sugar, oil and water, and chaat, where you can easily distinguish the different parts. It's important to remember the difference between homogeneous and heterogeneous mixtures. Mixtures can also be categorized based on the states of matter of their components, such as solid in solid, solid in liquid, or gas in gas. For instance, brass is a solid in solid mixture. An important type of solid in solid mixture is an alloy, which is a mixture of metals, sometimes with other substances, designed to have improved properties. Examples of alloys include steel, stainless steel, bronze, and brass. Indian rupee coins, for example, are made of alloys like stainless steel and cupro-nickel, which is a mixture of copper and nickel. This demonstrates how alloys are used in everyday objects due to their enhanced characteristics. Understanding alloys helps us appreciate the practical applications of mixtures in our daily lives. Mixtures have several key characteristics. They are composed of two or more pure substances, and their components can be solids, liquids, or gases. Importantly, there is no fixed proportion for mixing components, and the components do not undergo a chemical change. A crucial characteristic is that mixtures retain the properties of their individual components, as seen when iron filings are still attracted to a magnet in a mixture with sulfur powder. To understand the difference between mixtures and compounds, consider Activity 3.3. When iron filings and sulfur powder are heated together, they undergo a chemical change to form a new substance called iron sulfide, represented by the formula FeS. This new compound, iron sulfide, has properties entirely different from its original components, iron and sulfur, unlike a simple mixture. The key differences between mixtures and compounds are significant. A mixture is not pure, made of two or more elements or compounds, and not formed by a chemical change. Its components are not in fixed quantities and retain their properties. In contrast, a compound is pure, contains molecules of a single kind, is formed by a chemical change, has components in a specific ratio, and its properties are different from its components. These differences are vital for 6th grade students to remember. Separating mixtures is often necessary for various reasons. We separate mixtures to remove harmful substances, like stones from rice, or to obtain useful substances, such as petrol from crude oil. We also separate mixtures to get pure samples of substances, like purifying gold. These separations are typically done using simple physical methods that do not involve chemical changes, and the chosen method depends on the properties of the components. For solid-solid mixtures, several physical methods are used. Manual separation involves picking out components by hand, like removing stones from rice. Sieving separates particles of different sizes using a mesh, such as separating dirt from flour. Threshing separates grains from stalks by beating them, while winnowing uses wind to separate lighter husks from heavier grains. These are common methods for separating solid-solid mixtures. Other methods for solid-solid mixtures include sublimation, where one component changes directly from solid to vapor upon heating, like camphor from salt. Magnetic separation uses a magnet to separate magnetic components, such as iron, from non-magnetic ones. The solvent extraction method is used when one component is soluble in a particular solvent, allowing it to dissolve and then be separated, for example, salt from sand. These methods are crucial for separating different types of solid-solid mixtures. For solid-liquid mixtures, we use methods like sedimentation and decantation. Sedimentation is when heavier solid particles settle at the bottom of a liquid, forming a sediment, and the clear liquid above is called the supernatant. Decantation is gently pouring off the supernatant liquid, without disturbing the sediment. Activity 3.5 demonstrates this by separating sand from water, where the sand settles as sediment. Further methods for solid-liquid mixtures include loading and filtration. Loading involves adding a substance like alum to make small suspended particles clump together, become heavier, and settle more easily. Filtration uses filter paper to separate insoluble solids called residue from a liquid called filtrate. The liquid passes through the filter paper, leaving the solid behind, as shown in Activity 3.6 for separating sand from water. These methods are essential for purifying water and other liquids. For homogeneous solid-liquid mixtures, evaporation and distillation are key. Evaporation is used when only the solid component is desired, as the liquid turns into vapor and is lost to the air, like extracting salt from seawater in salt pans. Distillation is a more advanced method that allows both the solid and liquid components to be recovered. The liquid is heated to evaporate, and the vapor is then condensed in a separate container to collect the pure liquid, called the distillate, leaving the solid behind. This method is used to prepare distilled water. Choosing the correct separation method depends entirely on the properties of the components in the mixture. For heterogeneous solid-solid mixtures, methods like manual separation, sieving, or magnetic separation are used. For heterogeneous solid-liquid mixtures, sedimentation, decantation, loading, or filtration are effective. Finally, for homogeneous solid-liquid mixtures, evaporation or distillation are employed. Understanding these choices helps us effectively separate various mixtures. In summary, we have learned that mixtures are impure substances formed without chemical reactions, and their components retain their individual properties. We explored homogeneous and heterogeneous mixtures, understood the characteristics of mixtures, and compared them with compounds. Most importantly, we covered various physical methods for separating mixtures, such as manual separation, sieving, sublimation, magnetic separation, sedimentation, decantation, loading, filtration, evaporation, and distillation. This knowledge of mixtures is fundamental for your 6th grade chemistry studies.
This video was generated using evaly.com. It's the all-in-one AI platform where you can instantly turn any PDF into a video, generate interactive quizzes, MCQs, true or false, etc., from your content. Share quiz links instantly. No sign-up needed for your students or friends to take them. Check out evaly.com now and start transforming your documents into engaging videos and quizzes. I have added some sample quizzes in the description for you to practice.